Thanks for joining me here. We're going to go through parallel and perpendicular 3. We're going to talk about the converse of all of the statements that we did in parallel and perpendicular notes 2. If you did not do note sheet 2, note sheet 3 will not make a ton of sense, so you need to go back and do it. So we're going to talk about the converse. We got to talk about what that word means, and then we're going to use it. It's actually not that hard of a term, especially when it comes to math. Converses are pretty easy to figure out. All you've got to do is take an if-then statement. So if this, then that, and trade out the if part and the then part. They're just going to switch. So, if the Bengals lose to the Bills this weekend, then they are a bad football team. Now, I'm just using a Cincinnati example. You can use whatever example you want, but that's what I have. The converse would be what you would get if you trade the two parts. So you would then say, if the Bengals are a bad football team, then they will lose to the Bills. Now, I don't know if that statement is actually true. I don't know. Buffalo's 2-0 this year. I guess you never know. But that's the idea. You take the if part and the then part, and you switch them up. Now, today they're going to be true, but converses aren't always true. Let me give you a quick example. If a figure is a square, then it has 4 sides. The converse would be, if a figure has 4 sides, then it is a square. And as you can probably figure out, that statement is not true. So sometimes when you are working with converses, the converse is not actually true. Today, they will be true. Okay, so we're going to jump into bringing yesterday's lesson, or I guess whenever you did it, into today's. So we're going to consider all of the statements that we learned before. Okay, for instance, if a transversal intersects 2 parallel lines, then corresponding angles are congruent. Okay, so that would be, in case you forgot, we were doing these where we took a diagram and we numbered it from 1 to 8. You can do that right here. You don't necessarily have to, but I'm just going to kind of lay it out for you. Corresponding angles would be like angle 1 and angle 5. And we learned that if the lines here and here are parallel lines, then the corresponding angles are congruent. So angle 1 would be congruent to angle 5. We can actually look at this the other way around. Everything we did yesterday we can do backwards, because in this particular case, the converse is also true. So, look at it backwards. Now, instead of if the lines are parallel, then the corresponding angles are congruent, now we're going to say if the corresponding angles are congruent, then the lines are parallel. So now we can take diagrams like this, even if they're not marked as parallel. We can say, oh, look, this is 56 degrees, and this is 56 degrees. So now we know they must be parallel. So we're kind of opening ourselves up to being able to approach these problems from a different viewpoint. So when we name this, before we had the corresponding angles postulate. Now it's just going to be the corresponding angles converse postulate. Not very exciting. I think you can probably see it coming. The end of this note sheet is just going to be a lot of writing because all we're doing is basically taking the converse of what you already knew. Okay, so we're going to do a few more of these. I'll scroll down here. So, the next one that we did back on note sheet 2 was same side interior. And we know that same side interior, and that would be like angles 3 and 5, same side interior angles are not meant to be congruent. They're actually meant to be supplementary. Excuse me. So, when we go through this, that's what we're going to use. If two lines and a transversal form, and I'm going to run out of room, same side interior angles that are supplementary, then the lines are parallel. And so you can guess this one is going to be exactly what the other name was, but it's going to be the converse. And then this one happened to be a theorem. So again, we're just taking the same concept and we're looking at it from the reverse perspective. Okay. Now, I'm going to keep going. If you need more time to write, just pause the video. If two lines and a transversal form alternate interior angles that are congruent. Again, that was the third one from the other day. So that is not surprising to anybody. We want the alternate interior angles to be congruent, and if you're looking at the diagram, then I'm talking about something like 4 and 5 in this case, because they are on alternating sides, but they are both on the interior. If that happens, then the lines are parallel. So again, we're going backwards from the logic that we know about from the past. This would then just be called, you can guess it, the alternate interior angles converse theorem. I think what we can all agree on is that this process is very annoying, but it's not really difficult. It's just tedious going through all of these. Now, the last one that we practiced was alternate exterior. Same deal. We want the alternate exterior angles to be congruent. If they are, then the lines are parallel, and that leaves us with the last part. There you go. All right, now I don't normally do this, but the video finished so early, I just want to put 3 problems from the back up here real quick, just so you can see exactly how this applies. If you notice, the angle markings are not given on P and Q. We don't know if they're parallel or not. So we have to ask ourselves, are they parallel? Do we have enough proof to be able to say that? So we're going to go through and we're going to say yes or no, and we're going to give a reason why. So if you look at number 1, you have a 130 degree and a 50 degree angle, and they are both same side interior. Now our goal is for same side interior angles to be supplementary. So you check and you look and you see 130 and 50, that adds up to 180. That's what we wanted. So we would say yes. P and Q are parallel. We have proof. The same side interior angles are supplementary. So the postulate or theorem we would use would be the same side interior angles converse theorem. Okay, it's a lot of writing, but you got this. You look at problem number 2. You got a 70-degree angle and another 70-degree angle. They're both on the upper left of whatever corner they happen to be on. That would make them corresponding. We want corresponding angles to be congruent. 70 and 70, they are. It checks out. We have a winner. So that means yes, again. And then this one would be the corresponding angles, converse, and this one is a postulate. All right, now you look at number 3, and we don't have a name for 75 and 115. One of them is on the exterior, one of them is on the interior. We don't have a good name for them. So let's fill in some others here. Let's look at this vertical angle. Let's say, well, if this is 75, that means this would be a vertical angle, which would mean we would be able to have 75 here as well. Okay, so we have 75 and 115. So now our goal is to say, oh, same side interior should be supplementary. So we look and we take our 75 and we add it to 115. You get 190, which means they're supplementary. Wait. 190? We wanted 180. We got 190. That is a no-go. So, is it possible to prove that lines P and Q are parallel? No. It says, if so, state the postulate or theorem you would use. Well, it's not possible because 75 plus 115 equals 190, and that's not what we wanted. So instead of giving the name of a postulate or a theorem, just say no and maybe give me a quick reason. You know, okay, well, these add up to 190. We wanted 180, so it's a no-go. All right? So, got a few bonus problems, get you started in the right direction. I hope that helps, and I'll see you next time.